Hi everyone, my name is Vivian and we're going to be doing question 1 of Spring 16 Midterm 1. So this is IntList Essentials. Before we start, make sure you put your login in the top right hand corner because when we scan your pages, it's very unlikely, but sometimes we might lose a page and we need to be able to match your page with your midterm. So, number 1 is IntList Essentials, and it's asking us to recall the definition of an IntList class, which is here. And then it's giving us these random next one, next two, and next three methods, which are going to get called over here. And we're basically trying to figure out what these methods are doing. So when you're approaching this kind of question, it might help you to first look at what is being made. So this is a new int list that's being made, this whole 3 lines. And it'll help you to look at the int list and then call these methods and try to run through the steps inside your head. So first we're going to just actually take a look at these 3 lines. So the first one is saying IntList L equals a new IntList of 1, null. So if we have our environment diagram, as you recall from 61A, we're going to have L pointing to this list that has 1 and null, which is nothing. So the tail of our int list is not pointing to anything. So if you recall, an int list is basically this object that has a value and a pointer to the next thing. So it'll look something like that, where this is the value and this is the tail. So this is what L starts off as. So if we execute, so we've executed this line. Now if we execute the second line, L equals new IntList 2, L. Remember that the right-hand side gets evaluated first, which means we're going to look up what 2 is and what L is. Now 2 is just the number 2, but L is pointing to this, which means the tail of the int list that we're making is going to be pointing to this int list. So now L is going to be this 2 with this tail pointing here. And then now that we've finish the right-hand side, we will reassign L. Now we're going to do this again, except with 3 as a value. So again, L is pointing here, and then we're going to make an int list with the value 3 and the tail pointing here. And L is going to be pointing here. So now as you see, L is basically an int list that goes 3, 2, 1 from what we've constructed here. Now it's asking us to do next one of L. So let's look at what next one does. So next one takes in an int list, which is going to be L. So if we have a frame that's next one, it's going to take in a list, and this list is going to be pointing to L because that's what we pass in. And it's saying list equals list.tail. So what is list.tail? Well, list is pointing to this int list, and the tail of this int list is pointing here. So all we're doing is reassigning list to be list.tail. A common misconception in this problem is that you actually think that L starts pointing to its tail. But because the way a function works, when you pass in a value to the function, only the pointer gets copied. So the variable L itself is actually not affected inside your function. So now all that looks like is just list pointing to the int list 2, 1. So when we're going to print out L.val, L is still pointing here, which means that L.val is still 3 and not 2. So now we're going to do next 2. So let's take a look at what gets passed into next 2. It's another list, and because our L has not changed, it's going to be pointing here. Now when we look at next 2, it's going to say list equals list.tail, so that's the same thing as next one, so we're just going to move the pointer here. But then it's going to return the list. Now, does this returning the list matter in this case? It actually does not, because we just call it and we do not do anything with the return value, so it kind of just disappears off into the garbage collector. So now when we print out L.val again, we see that L has not changed its pointer. So because L has not changed its pointer, L.val is still here. It's 3. Cool. So now we're on the last one, which is next 3 of L. So when we do next 3 of L, it's saying IntList temp equals list. So let's make our frame. So list is pointing here because L has not changed. And then temp is also pointing here. Now it's saying temp equals temp.tail. Well, what is temp.tail? It's temp pointing over here, and this thing's tail is here. So we're just going to change the pointer from temp to go here. Now again, notice that L has not changed. So when we ask for L.val, it's still 3. So the answer to this part A was 333. So now let's do part B, which is telling us to fill in strange insert front so that both print statements at the bottom of this page print out 0, 1, 2, 3, 4. So the interest why this is a strange insert front is because we're inserting 4, 3, 2, 1, 0, but it wants us to print out 0, 1, 2, 3, 4, which means it wants us to print out the reverse order that we inserted in. There's also an IntList L2 equals L, so L, and then L equals L.strange insert front 0. And now L2 also has to print 0, 1, 2, 3, 4. So this is a catch. It's a gotcha because you might be like, oh, to reverse the insert front, I should just set this to be like, I shouldn't mutate the list, but instead I should just create a new list where like it's kind of like reversed. But in this case, you're returning this, and in Java this means return the current object. So you're going to have to mutate the current object in order for these two print statements to be the same. So knowing that, let's look at what this is supposed to turn into. So when we have this first line, we're going to have IntList that's for and null. Now when we do a strange insert front on 3, what's supposed to happen is that because we are returning this, so L is currently pointing here, because we are returning the object itself, what's supposed to happen is that the object itself gets mutated, which means because if L and L2 are both pointing here, and we only set L to like be the new pointer, and we want both of them to stay consistent, this object itself is going to have to mutate, which means the object itself is going to have to, when we insert 3, it's going to have to become 3 pointing to 4 and null. Because you might be tempted to just like return a new int list with like x and this. But what then happens is that you're not mutating your current int list, you are just returning a new int list. So if we have L and L2 pointing here, and we just return a new int list, x comma this, and say we inserted 2, what's going to happen is that we're going to have this happen, and only L is going to be pointing to this new int list, because we only set L to be what it returns. So that's why when we return a new int list of x and this is bad. This is wrong. Because L2 isn't going to be updated. So let's actually try to think of a way to mutate this linked list to become this. What that actually means is we're going to have to mutate this box itself to turn into a 3 and into a 4 and nothing. So how do we mutate the list? Well, we're going to have to change this .val to 3, and then we're going to have to change this .tail to be that. And then of course we're going to have to like make 3, or we're going to have to make this int list. Okay, great. So how do we change this .val to be 3? Well, that's just a simple assignment where we go this dot val equals 3. So we can check this off by doing that. How do we change this dot tail to be 4 and x? Well, remember this was the old this dot val, and this was the old this dot tail. So you might be tempted to do this dot val equals 3 and kind of like call it a day and be like, okay, let's change the tail now. But then by reassigning this dot val to be 3, we kind of have lost the old val, which means we kind of have to create a duplicate of this list so that we can bind our tail to be what our old this dot val and this dot tail was. So to kind of clarify this, what we're doing is that if this is our original, so this is our original object. So original, and then in text we can be like val is 4, and then tail is null. What we're doing is that we're not creating like a new int list and returning it. We're actually going to take our original and change the val to be 3 when we're inserting 3, and we're changing the tail to be, we're going to change the tail to be pointing to this 4 and x. So we are making a new int list, but it's not going to replace our current int list because we're mutating it. So that means we can't do this dot val equals 3 first, because we still have to make a new int list with the original this dot val and this dot tail. So we have to set our tail to be this. So we have to make a copy of the original, and then we have to set our val to be the new x. So let's do that. So how do I make a copy? I want to make a new int list that has the parameters this dot val, and this dot tail. So I made our new int list, but now we have to set the tail to be that. So this dot tail is now this new clone of our original. So that can accomplish this part. The reason we can do this is because the right-hand side gets evaluated before we do the assignment. And then we just have to update this dot val to be x. And we're done.